I'm Spratt. I'm with Southern Company, electrical and gas utility out of the southeast United States. Why I'm here specifically is Southern Company also operates Southern Link Wireless, which owns and operates a private LTE network across Southern Company's distribution footprint. So that's all of Georgia, all of Alabama, parts of Mississippi. And I lead the team that secures our telecommunications, so our private LTE being a very large part of that, as well as our fiber optic, microwave, satellite, carrier pigeon. You know, if it's passing packets, we got to secure it. So I'm going to let my fellow panelists here introduce themselves real quick, and then we'll get into what we're doing here today and why. Ken, you want to start?
Yeah.
You're right.
Yeah, so my name is Ken Kaminski, and I am Ericsson's Director of Cybersecurity for their Private Networks division. So I handle everything that's cyber related for all the various private networks that are going in. One of the biggest markets right now is obviously utilities, where private LTE is going in at a fairly rapid rate. Also work in other verticals like defense, Department of Defense, large enterprises, and things like that.
Hey guys, my name is Liron Ben Horin. I'm the VP of System Engineering at OneLayer. OneLayer is a company that provides a cybersecurity software solution for private LTE networks, as well as a device orchestration solution. We work very closely with Ericsson, Southern, and some other utilities. The key of the solution is mainly to be able to collect information directly from the cellular core in order to be able to learn more information about the devices and to use this information so that you can make better decisions in your network. And we'll talk about it a little bit more later.
All right, we're not going to do death by PowerPoint. It's the last day. This is going to be a conversation. I think a lot of times when I do a panel, I'll sometimes joke this is really just a meeting that I've been wanting to have for a while. So if you have questions, please stand up and join on in. I know Ken and Liron will be able to stay afterwards and talk as well. But getting started, as a broad kind of understanding, where do you both see operational efficiencies meeting with security concerns? Because I know as a utility, when we talk about our private LTE networks, yes, the A in our triad of CIA is availability, so network availability is important to us. When you take the word private in private LTE, it allows us to scope down our use cases, so we're not trying to be all things to all people. But Ken, we'll start with you. Where do you see those two different opportunities meeting between operational efficiency and security programs, because inevitably there is going to be where we end up at cross purposes?
Yeah, one thing I've noticed, we were chatting about this the other day, I've noticed a pattern in the utilities. And the pattern is that a lot of your funding is available right up front. So you get a big pile of money from the the various, you go through the regulatory process there, and then you get a pile of money in order to pay for it. And the need for operational efficiency drives that network down to just exactly what you need. And what we've been noticing is that some of the cybersecurity aspects of that have been missing. And the right time to put those in is right up front during these initial deployments, because that's when the most money is actually available. And the things that have been missing, generally folks are kind of concentrating on the cyber features that are built into the network itself. And it being mission critical gear, there's quite a bit of that. But there's a couple of other areas that have been missing. So there are products that basically secure the actual infrastructure itself. Think of them as like an add-on product there that deals with use cases like automating security configurations and auditing. The threat management pieces of that, like looking at the logs and taking into consideration all the different attacks that are coming in, and how to analyze all that data, dealing with false base stations, and then endpoint detection and response agents that are required in a modern cyber architecture. So that's missing. The device component also gets missed, which Liron will talk about. The technology that's needed in order to secure those particular devices themselves. And then also thinking about some adjuncts like next-gen firewalls. You're going to need a couple of those in the roaming space with very specific features. So my recommendation is to think about cybersecurity as a broader picture right up front while you actually have the funds available. In a modern mobile network operator's network, about 5% of the actual spend is cyber related for people, processes, and technologies. So think about that in terms of that, and think about these other pieces that will be added. Because folks are adding them on the back end when the money is less available.
I think one of the really interesting things that separates utilities from other industries when it comes to private LTE is that the huge geographical areas that they need to cover, and the fact that they need to cover entire neighborhoods, entire states, will lead to them setting up tons of devices to test various use cases all over the country, right? And when you do that, it's fantastic for operational purposes because suddenly you can benefit from having meters running over private LTE, subsystems, and tons of other use cases, so you become more efficient when it comes to operations. But then again, a key challenge when you do that, which is not necessarily exclusive for private LTE, it's just the nature of these types of applications, is that everything is spread out. So you have a lot of devices all over the place. Some of them you're not necessarily the one to install yourself. Others, if there's something anomalous occurring, it's very difficult to be able to detect that in real time. So the need to always be aware of where are your devices, right? Like, what are they doing? Is everything according to plan? Is nobody messing with them, right? Nothing malicious is happening. Nobody's taking a device, moving it around, maybe taking the SIM out of a device, trying to connect a rogue device. This becomes like a very key challenge because on one hand, from an operational perspective, you always want to add more and more use case and justify the already quite heavy spending that you've done to really benefit from private LTE. On the other hand, you really, really want to make sure that you have the right mechanisms in place so that these devices can also be secured and not only around and you have no clue what's going on with them.
Thank you both. No, I think it's very important. You're talking about the front loading of that funding. That's really a big part of what utilities do a lot of times. And you're right, you get down the road a little bit after that project money is done and you're still left with needs that you discover. So understanding that up front is very big. What have you seen from your customers, other utility customers, and how they can maximize efficiencies that they have from their existing networks today? How can effective security approaches help in that regard? And again, talking about the finite amount of people, the finite budget, whether it's something X as a service in the cloud, or what have you seen from previous customers, how they've handled that?
I think one of the keys there is automation. And these networks are modern, they're complex, and the more automation that you can build into your processes, the better. So one area would be like, for instance, in the NERC SIP space there that you guys are under, if it's the bulk electric system portion that you got all these devices loaded up on, there's requirements to actually look at the security configurations, look at baseline configurations on devices, and then audit those on a regular basis. So if you can get some tools that will allow you to go ahead and automate that process, so you don't have your actual people doing that, that's a really good thing to do. So that would be kind of one area. Look across the board on the cyber side, see what you can automate, and then go down that route, because that'll save on people time also.
Yeah, I 100% agree. I would just add to that I think when we speak of security, to me, the very first building block for every security solution is to have better visibility and understand what is the state of your assets. Because in the end of the day, when we think of security, oftentimes we want to do proper segmentation. We want to be able to receive alerts in real time. If you want to do that, the first thing you need to know is what are your devices? Like, where are they? What's their nature? How do they behave? So it's, again, like visibility is like the first step for you to be able to do all those next phases, right? And when we speak of automation, I guess the best approach is if you have like a mechanism in place that allows you to understand exactly what it is you have in your network, and only once you feel like you got that part covered, do you move on to the little bit more advanced stages of security, where you make sure that now you can make arguments like, okay, I don't want this set of devices to communicate with that set of devices. Whenever a certain behavior occurs, I want to be notified about that in my internal systems. So these are all related and have to go together.
Thank you. Again, automation being an example, because I've never been a part of an organization that claims that we have all the money we need and all the headcount that we need. We could always use a little bit more, but trying to become efficient in our security as well as our operations is really important. So, Liron, I wanted to ask you specifically now, when you see the requirements that utilities are asking for on end devices, how do you address those unique challenges, but also how do you see the difference between what a utility is asking you versus what a regular mobile operator would ask?
It's a great question, and I think it really shows the shift between the mobile network operator world to the more enterprise and utility world, where if you think about it, take an MNO like Verizon, AT&T, when they have tons of SIMs that were scattered and given to users to use, like the B2C environment, they don't really care what you do with that SIM, right? Like you can put it in a tablet, you can put it in a phone, you can put it in a modem. The thing is, like, this is up to you. And if there's an issue with your phone, because let's say you are hacked or something like that, and you call Verizon and you'll tell them, hey, someone's been messing with my phone, then tell you don't press that link, right? Like this is not us. Like what they care about when it comes to security is more about making sure that nobody can mess with the core components. Nobody can make it so that the radio parts won't work. Nobody will get access to their billing servers and affect pricing, right? When it comes to utility and enterprises in general, it's a little different. Because now you add that component that if someone somehow was able to gain access to one of your devices, suddenly they can do some real trouble in your network, right? So it's no longer about just like, where are my SIMs? It's more about like understanding exactly what are the threats, what are the devices, having solutions in place so that if there's an issue with the device, you can detect that. You can understand that's the device that's the one that's looking malicious right now. That could be the source of the attack. So it's really different in the state of mind when it comes to security, when you compare an enterprise to an operator. Okay.
Yeah, and the enterprise systems that have been built and designed were not built around the cellular network. So for instance, we're used to in the utility space or the enterprise space, we use technologies like network and mission control, various identity engines from different vendors. And that technology is all built around the traditional access that you'll find in a network. IP connectivity, Ethernet, wireless connectivity like Wi-Fi and whatnot, and remote access. The cellular network has a completely different access architecture here. So those systems that we've relied on, they don't match the requirements. So we really have to look to vendors like OneLayer in order to go ahead and meet these requirements on the cellular side. And you have to have it, right? You have to have control of these devices. You've got to know that these are your devices that are connecting. And these are all IoT devices also. So there's no way to roll out some type of a security agent on that device like we do in the traditional enterprise. If I've got an iPhone, or an Android or a tablet or something, I'll go to my EMM vendor, my enterprise mobility management vendor, I'll pop an agent on there, and I'll be able to control that from a security standpoint. But in this world that we live in on the utility side, these are all IoT devices, so none of those solutions really match.
Excellent points from both, and I love Liron's point here that as we as a utility, it's our private network. We can't just stop carrying a SIM card, and even the device itself. We own the network, but we're also the operating company. So the things that plug into the fixed devices are also ours, and so having a much broader view on security, and that's thus part of the title to our talk. It's an ecosystem that's more than just the network. You have to care about the devices as well. Ken, even though we're running a private network, whether it's due to the FCC wanting to increase resiliency and reliability, or even pockets of coverage or wanting some sort of failover, we end up talking about roaming. So when we talk about having interconnected networks, what can utilities really do to increase the data integrity and the privacy for our customer data when you talk about roaming security?
Yeah, so this is an area where, this is one of those areas where people are realizing I do need some controls here, later on in the game. So this is a very telco-specific discussion when you get into this. And roaming security is a very specific area in the telco space. But there's a couple of kind of larger concepts at play that you can kind of get the major pieces. So first of all, there's a signaling interface running a protocol called diameter, which is just a variant of radius that you're used to in the enterprise. The signaling's going over that, and when a device roams to another network, the user plane or the user traffic will be coming back in to your network running a tunneling protocol called GTP. So you'll want to make sure that your next-gen firewall vendor that you're using, they all have telco software loads. So it's not going to be the standard load you're using in the regular part of the enterprise. You're going to ask them about the telco-related loads that can support those features. And in that firewall there, you'll put it between you and the roaming partner. It'll look at those protocols there, and it will properly firewall those. And then you'll build an encryption tunnel using IPsec to that roaming partner in order to encrypt that traffic. So that's one area that you'll want to do. The other area gets into a little bit more esoteric kind of attack scenarios. But there are these very specialized signaling firewalls in the telco space. And the roaming partner that you use will probably have one there. And you'll want to talk to them about the realities of your network. You have IoT devices, these things are never going to roam. So the firewall rules that will be set up there will be very unique to the utility environment, and so that outside actors are not able to come in, figure out, different types of intelligence on your devices and whatnot. So that will be a discussion you'll have with the roaming partner about, hey, this is what my network looks like. I want you to protect the signaling piece of this and make sure that that happens.
I don't have much to add to Ken's point. I will just quickly say something that I hear from a lot of utilities in the context of roaming. Roaming is a mandatory or inevitable part of a private LTE network for utilities, because when you have mission critical communication, you always need backup to your backup to your backup to make sure that no matter what, you'll still be able to transfer the data. And I think another challenge that exists currently for roaming that needs to be addressed is that there really aren't a lot of tools in place to even allow you to understand when sometimes roaming is occurring. Like when you have a device transitioning to a public network and then maybe going back to a private network, being able to just determine in real time where that device is so that you can start to query it, ask the network questions, have a better understanding of your inventory, that's a whole separate set of challenges. So it has nothing to do necessarily with the signaling aspects of it, but I think another component that needs to be thought of when you go the roaming direction is how exactly you can have as much information about where are my devices right now. Are they operating on the public infrastructure, on the private one? Can they be transitioned between if I need them to? So just another thing to keep in mind when you speak of roaming.
That's a great point, because we do have a lot of unique challenges when you're operating a private LTE network, and one of those was prompted by what you were saying there about the specifics of a signaling firewall. But how do you integrate with existing network security solutions that utilities use today? When you're talking next-gen firewalls, IDS, IPS, full packet capture, our SIM and SOAR functionalities, we're dealing with different protocols. This is not your very IT-centric, something that I can pull out of the box and say, poke it with a stick and say, do your thing. How do you integrate, and where do you see which ones are important to you, really?
Yeah, there's a number of those. One of them would be what's called the SEM, the Security Information Event Management System. And these are usually vendors like Splunk and some of the other leaders in the space. In all of your security operations centers, this particular piece of technology is at the center of your defense system. And you've got to go ahead and send all the logs from the radio portion of the network and from the core portion of the network up to that specific piece of technology. Now, a caveat with that is that out of the box, those vendors tend to support rule sets for all of the various types of vendors that you'll find that are common in a utility or an enterprise network. These rules are not specifically written for the telco environment. So you're going to have to do one of two things. You'll write them yourselves. So hopefully you got a really good SEM guy that can do that. Or you'll buy one of those tools that I was talking about, in Adam's first question here, that help to secure the infrastructure. Because those specific tools are written for a cellular environment. They'll process all that information, and then they'll go ahead and tell your Splunk system what's going on. So that's kind of one area of integration. Another is around your next-gen firewalls. I kind of touched on that briefly. You're used to dealing with vendors like Palo Alto and Fortinet and Cisco and Juniper and whatnot, and you're going to deal with those same vendors. It's just that you're asking them for a different software load that understands these specific protocols that are running in the cellular network. It's all IP like you guys are used to, so it's all IP packets, but there's a different, instead of TCP, it's a protocol called SCTP, which has more availability built into it at layer 4. Instead of regular tunneling protocols that you might be used to, there's a different one at layer 4 called GTP. So these firewalls need to be able to understand these protocols and then operate. Another kind of one of the last areas here that you'll want to think about is for network taps. So if you're going to tap a core, a modern cellular core, which is really the brains of this network, that entire core is really just running Linux containers on some type of a full stack cloud operating system. That's almost always how it's deployed. And if you want to tap that, those are Linux containers. So you're looking for a virtual tap somewhere. That container could be spinning up across all these different servers, and it could be coming up and down depending on the load. So you need the taps actually built into the software applications themselves that are running on the core. And it's interesting, those taps are running just HTTP REST API calls between the different functions that are controlling the network. There's no underlying, MAC header or even an IP header there. It's going from one part of the Linux kernel to another there. So in order to talk to a tap, these features actually have to build the IP portion and build it into a format that your NetScouts of the world and the others understand. So those features are built into the core. You'll want to ask, a vendor like Ericsson, if you do want to tap that information, we need to include those features, within the deployment for you to do.
Thank you. I'll take a bit of a different angle. I think that Adam here gives you the impression that this persona that knows both cybersecurity and LTE is a common one, but in reality, it's more complex than that. And usually, when you, as a utility, start building your own network, you'll have the people that are more, IT professionals, and they might understand the ins and outs of LTE because they need to now that they have this network. And then you'll have people that are more security oriented. And a lot of what I see more often than not is that the people that know these security products, they know how to operate them, they know how to set up the rules, they know how to manage inventory, they know how to detect alerts. They don't know what cellular is, or barely know what cellular is. And it's like a long journey for them to be able to gather that knowledge. It will happen eventually, but more often than not, it's not a trivial transition when it comes to leveraging all your existing knowledge that you have for security and sort of implementing that now in the LTE environment. And to me, one of the key things that we were doing in OneLayer when we were starting to come up with our solution is to sort of try and tell that narrative that rather than force a whole new lingo here, because security is such a complex world and LTE is a whole other complex world, we sort of tried to make a common language where you don't need to be a cellular expert in order to start and manage your cellular network securely. So the key here was to sort of allow you to do all those integrations that Ken was referring to make sure that you can use your existing firewalls to set up rules for the LTE that are effective. To make sure that if you have like a Splunk that gets all the alerts, so that you can have those cellular alerts at the same place where the IT and OT security teams are already seeing all the other alerts, right? So I think the goal here is, like from my perspective, is to try and not make cellular like its own thing, but rather to allow the existing security tools that you have in place to really be able to see cellular events, to understand cellular devices, to set rules for cellular devices. That's something that will really ease the process of adoption here and to enable more use cases.
Excellent, thank you. I know we're getting close on time. I wanted to ask one more question. I loved how you introduced that last thought though, because Liron, you're exactly right. I tell people I couldn't spell LTE when I started working on these networks, but now that I've been in securing telecommunications for a little over a decade now, it is a very unique skill set to, if you got your Venn diagram up there, to understand utilities, telecommunications, and cybersecurity. But giving everybody here about 60 seconds to talk about this, Ken, can you give us an overview of how we can achieve zero trust architecture in a private LTE network from the network side?
Yeah, that's a very large topic there.
Go ahead, 60 seconds.
Yeah, 60
You got
seconds.
this,
So,
you got this.
well, zero trust, first of all, what is it, in a nutshell? Traditionally, cybersecurity we've looked at as like a castle and a moat. So we build all our defenses around a perimeter, but if you get through that perimeter and into the inside, you have pretty much free reign. Zero trust was a concept that came around a number of years ago from the enterprise space. And the main idea is that there is no secure location you can count on. So every device, every user, and every session has to be authenticated and authorized, and everything needs to be encrypted and protected. So there's no secure areas anymore. Everything is with the understanding that there's tanks inside the perimeter. And in the cellular space, there is movement within the standards bodies to integrate this concept into 5G. So the main problem that we have on the LTE side is we've got to take these concepts and then roll them back into 4G. And there are some areas of the network that this works quite well in, like the radio portion of it. We can definitely do that. But in the core, it's a little bit more challenging because of 4G core. Once you get into it, there's no encryption, or authentication going on between the machine functions that are in there. It's very different in a 5G world. All of those software applications are encrypted and authenticated to one another. So you'll have to build some more defenses, around the core there in order to try and compensate for that. And that's coming, by the way. This is coming to the utility world. The US government has mandated it for all of their agencies. In the military space, this has been mandated. A lot of the financial companies that are out there, are rolling this out. And it's only a matter of time before the federal government tells the utilities that this is what you're going to have to do.
Absolutely. I'll try to keep it really quick. Zero trust is not unique to private LTE, right? It's an approach. It's something that you want to have if you want to feel like you're more secured, like you're following the right standards, and you have the right means to secure your network. And I think in the end of the day, private LTE is a method to connect devices that would otherwise still be connected to your network, be it through other means of telecommunication. So there's the need to have zero trust implemented is just by design of the application that you decide to run in your network. And because of that, it will sort of sum up everything I said so far. Your need is to first understand what devices you have in your network, and on top of that, have the tools to properly segment your network so that no device can communicate with whatever it is that it wants to communicate with, but rather they have in place rules that enforce it to only do what it was designed to do. So that's how you can follow zero trust, be it in private LTE or in any standard OT environment.
that'll be our time. I'd like to thank Ken and Liron. Thank you so much for being here on this panel today. Thank you for attending. If you have any questions, we'll be around in the room or at the Ericsson booth downstairs. Thank you, guys. Thank you.
Thanks.
Kind of alluded to maybe like the middle layer. I imagine a lot of devices emitting stuff, and I already paid my plug license, even truckloads, go beyond.
Yes, yes, yeah.
What kind of